name's Elizabeth Fisher and I'm Professor of Neurogenetics at UCL and I work at the Institute of Neurology. So the big question in our lab is why neurons die, and we're very interested in neurodegenerative diseases. So for many neurodegenerative diseases we can say that we know some of the genes that are involved, but we also know that generally they're untreatable and incurable. This is really across the board. So we'd like to find out more about why neurons die. And in many cases we know some of the genes that cause the different neurodegenerative diseases, but we're still very far from understanding mechanism, and until we've really got a good handle on mechanism, it's hard to come up with treatments for these diseases. So that's our interest, particularly in two key areas. One is the Alzheimer's disease that arises through having Down syndrome. People with Down syndrome are at a very much increased risk of Alzheimer's disease. And the second disorder that we work on is amyotrophic lateral sclerosis, which is otherwise known as motor neuron disease. The research that we do is important to society because neurodegenerative diseases are massively on the increase all over the world, and that's simply because we have an ageing population. People with advances in medical research are just living for longer. But having said this, we often think of neurodegenerative diseases as being late onset, as being something that happens to people, say, over the age of 60. This isn't the case. There's a proportion of people who are affected very much younger. And to give you some idea, with one of the diseases that we work on, amyotrophic lateral sclerosis, it's classically thought of as a late onset disease over 60. In fact, there are people in the literature as young as 11 who've been described with full-on disease. These are very, very rare cases, but neurodegeneration can happen at any age, although it is skewed towards the older population. These disorders, again, are untreatable and incurable, and they're a massive, massive load, not only on people who suffer with these diseases, but also on the carers and the families and friends of these people who are watching the progress of the disease. Our research is orientated towards mouse models, and so we are creating new mouse models of these particular disorders, and this is something we think about very, very carefully before we embark on these sorts of projects. And so we create the mouse models, which we then publish. They're sent out to other labs around the world to work with, and we also analyse the models ourselves. This is very much ongoing work, as you can probably imagine, but the sorts of things we're finding is we think we have a new gene that may be important with people who have Down syndrome and may help to predispose them towards Alzheimer's disease, and that's important for the rest of the population because that particular gene may turn out to be important in other individuals who don't have Down syndrome, who have a normal chromosome number, but who get Alzheimer's disease. And similarly, we have some very interesting findings with mouse model for one of the genes that gives rise to amyotrophic lateral sclerosis, and we're finding some changes at the level of RNA, at the level of how genes are transcribed, that may be relevant to how the disease causes specifically motor neurons in the body only to die.